This is 7th grade, Chapter 6 review. All this is really fairly easy if you only remember the formula. Y equals mx plus b. And you have to remember that m is slope and b is your y-intercept, which means that line is going to cross over the y-axis at that point. Okay, so let's look at number 1. I have 2x plus y equals 12. But that's not in my form. So let's just change it to where it is. We know how to move numbers and letters around. I want to get 2x on this side of the equal sign so I can get y by itself because that's the way my formula looks. In order to do that, I've got to take 2x and cancel it out on this side to move to this side. And this is a positive 2x, so I need to subtract 2x, and that cancels out, and I must do it to this side. So now you have y equals negative 2x plus 12. 12 is positive. I'm going to keep it positive. And so now it looks like my formula. Now I know what to do. This represents slope. This represents y-intercept. So let's look at our answer choices. Well, if I know the slope is negative 2, it says slope is 2, nope. Slope is 12, nope. Okay, so now I'm down to 2 choices. And it says y-intercept is 12. Well, D says it's negative 12. That's wrong. So my answer is B. When you're going through these, you need to use the process of elimination. It will really narrow your choices down to usually 2 answers. Do that on all of your tests. Number 2 says write an equation in the form of y equals mx plus b of the line shown in the graph. Then give the y-intercept, the slope, and the x-intercept. Now then, we haven't talked about the x-intercept, but let's think about it. If the y-intercept is where the line crosses your y-axis, what would your x-intercept be? X-intercept should go where it's going to cross the x-axis, which is right here. And then, let's see, find the slope. Remember, your slope is rise over run when it's graphed. That's the easiest thing to do, is rise over run. So I need to find 2 points that are going exactly through the plots here. Let's see the lines. Here and here. We'll use those 2. So then you have rise over run. But look, our line is going down. So I can't rise if my line is sloping down. So that would be a negative slope. So instead of rise, I fall and then run. Okay, when it's negative, you fall and then run. Or drop and run. Okay, as long as you know you have to go down, drop, fall, whatever, just go down and then run. So I'm going to go down 1, 2, and I'm going to go over 1. So when you fall or drop, your slope's going to be a negative. And it was dropping 1, 2, and over 1. So negative 2 over 1 is your slope. Now then, all you need to do is look very carefully and cross out anything that does not match what we found. Okay? Look very carefully at your answers, eliminate your choices, and read all the way through the end. Number 3. Brian has a balance of $320 in his checking account. He spends $15 each week. If you spend money, you're taking it away. If you spend it, you're losing it. It's a negative. For the next 8 weeks, if you were to graph the linear relationship, what would the numerical value of the slope? What would the slope mean? Okay, again, look at your answer choices. And we know he spends, he doesn't earn, he's spending, and we know spending would represent a negative. Okay? Process of elimination, look through everything carefully. They're going to try to trick you with their words. Number 4. Write the equation of a line that represented by each table. Remember, we said you can find the slope, which is m, equals y2 minus y1 over x2 minus x1. And you can do that by finding your pairs, your ordered pairs, and labeling one x1, x2, y1, y2. It's really the change in y over the change in x. So when I find my change in y and my change in x, I'm simply going to do it this way. Find the change. Going from a negative 2 to 0 was a change of 2. 0 to 2, a change of 2. 2 to 4, a change of 2. 3 to 2, 1. 2 to 1, 1. 1 to 0, 1. So my change in y is 1 over my change in x is 2. And it's a negative 1 because we went from 3 to 0. So we're going down. Remember, if you're going down, that slope's going to be negative. It's going to go that way. So that's your slope. Remember what we said about the Y-intercept. The Y-intercept must cross over the y-axis on this point. So if I were to graph this, and it's your Y-intercept, and this is y, it's got to hit this line. To hit this line, your x would need to be 0. And then what would your y be? Wherever it crosses the y-axis. So let's find if any of these have an x0. X is 0, so your y-intercept is 2. So there's your y-intercept. Now, you create the formula, because you know y equals mx plus b. And you know m is your slope and b is your y-intercept. Number 5. The table below shows the number of inches in x feet. Graph the data, then determine the slope of the line. Explain what the slope is representative. Okay, remember, slope is change in y over your change in x. Find your change find your slope. And you'll find your graph. Okay, this is your 1. This is going up by 12s. So your change in y, this is y, this is x. And you can also, if you don't realize that, you can look feet, feet. This is your x. Inches are going up, so that is your y. Change in y over your change in x. And then which one has it graphed properly? But not only is it graphed properly, you have to explain it properly. Okay? Oh, same one. Number 6. Graph y equals negative 3x plus 2. Okay, remember y equals mx plus b. Okay, m would be by your x. Your b is the number past your x. So your slope, your m, is negative 3, and your y-intercept is 2. So which graph has the y-intercept at 2? That's going to be your best thing to eliminate your choices. I would go and circle all the 2's. Y-intercept, 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 Y-intercept. That's where it should be intercepting. It does not do it there, and it does not intercept there. Okay, so now then look at your slope. Remember, it's rise over run. But all of our slopes are negative slopes because it is a negative 3x. So instead of rise and run, you're going to fall and run or drop and run. Negative slopes. Okay. So out of the 2 remaining, which one can you fall 3, and run 1? Because we know a whole number can be turned into a fraction by placing a 1 under it. So you fall and run, or drop and run. So pick a point on the line. I would start with your y-intercept. Drop 3, run 1. And where you hit that line is, if it's right there on that point, that is your graph. I'm trying not to give y'all all the answers. It's hard. Okay, number 7. So again, we're just graphing this equation. Well, remember, slope, y-intercept. So just because it's a negative x means that it's going to be a negative slope. And all my answers are negative slopes. So then I would start out, negative 1 is my y-intercept. So I would find every single one. I would go and circle just like we did on question 6. Go circle your y-intercept. Where does the line cross the y? And then you should have your answer. Number 8. Determine the slope and y-intercept of each linear equation. y equals negative 3x. Remember, just because there's nothing here doesn't mean that's not our formula, because we can pretend that it's plus 0. So again, y equals mx plus b. Slope, y-intercept. So, out of this formula, which one is your slope and which one is your y-intercept? And look at the answers very carefully. Number 9. Write the equation of the line that is represented by each table. Okay. So we need to find what is my slope and what is my y-intercept. And if I can find those two things, I will know what my equation is. If you don't understand slope and the y-intercept, you could substitute your x's for your x's and see if you get the y. Okay? It's not what we want you to do, but it's always at a last resort. You could plug in your x, and you should see after you solve the problem if you get your y. Or, let's find slope. Change in y over your change in x. So, find your change, and then your y-intercept. Remember, your x has to be 0, and then that's your y-intercept, because it's going to cross on your y-axis. But you're saying the table doesn't have 0 on it for an x. Okay, problem solve. It's going up by halves. Add a half, you get 1. Add a half, you get 1.5. Add a half, you get 2. So your change in x is a half. Okay, so I know my change in x is a half. The change in your y from 15 to 8 is going down, so I know it's going to be a negative. 8 to 1 is going down, so it's going to be 15. 8 from 15 is 7. 1 from 8 is 7, and negative 6 to 1 would be a change of 7. So this would be change in y would be negative 7. Again, you're saying, well, that's not on the chart. Problem solve. Let's solve for your y-intercept, because that'll eliminate two choices. If I want my x to be 0, x needs to be 0. How can I get to 0? By subtracting a half. So that means I must be able to subtract 7 from 15 to get my y-intercept. And actually, you're not subtracting it from 15, because if you do that, you're going down. So if you're subtracting from 15, you're going to get 8, so that's going down. It's a negative slope. So we actually need to go up, because if this was your graph, and it's going to cross your y-intercept, and at 1/2 x, it's going to hit the y-intercept. So it's a negative slope, so it's going to go down. So this part has to go up. So we're going to add 7 to 15, and that would be 22. Now then, if I subtracted 7 to here, it's going to get 15. So your y-intercept would be 0, 22. Okay, but now we're going back to the slope. What kind of problem is that? It's a division problem. So let's divide. Okay, it's going to be negative because we have one negative. It's going to be 7 and 0.5. I need to move my decimal over. So move a decimal spot over and add your 0. And now see if you can solve it. Number 10. Determine whether the relationship in each table represents a linear relationship. Remember, linear relationship has to be a constant rate of change. Constant rate of change. So you need to find your rates of change. Find the change in your y, find the change in your x. See if it's a constant rate. Linear relationship has a constant rate of change. Read the answers very carefully all the way to the end. And if you come across something that's negative, that's false, cross it out. Process of elimination. Number 11. Determine the slope and y-intercept of each equation. So again, I have an equation that it's not in the form I want it in. So I'm going to have to make it into my form that I'm used to looking at. So number 11, if I have y plus 4x equals negative 1, I want to get y all by itself because I'm used to seeing my y equals mx plus b. So that's what I want it to look like. So y has to be by itself. I need to get 4x on this side. To do that, I have to cancel it from this side and make 0. And then I can do it on this side. So that's going to equal y equals, and my x usually comes first, so negative 4x minus 1. Okay? Now then, since we have it written in the proper form, remember where your slope is and remember where your y-intercept is. And by looking at this formula, you should be able to tell what is your slope and what is your y-intercept. If you have forgotten, look back at your previous notes. I know I've labeled it. Number 12. What is the slope of the line containing the points in the table below? Remember, slope, slope, slope. Change in y over change in x. This is x, this is y. Change, find the rate of change. From 1 to 5 is 4. From 8 to 40 is 32. So the change in y over the change in x. You're going to get an improper fraction, and you need to simplify that, and you'll find your answer. Okay? Be very careful. Look at your signs. Don't get tricked. Number 13. Write an equation of the line that is represented by each table. So we need to know what is our y-intercept. Remember x, y. To be the y-intercept, x has to be 0, and that is your y-intercept. Do we have a x that's 0? Right there. So we know what our y-intercept is. And to find your slope, it's the rate of change. Okay? Rate of change over y over x. Change in y over the change in x. And once you have that, you should be able to plug it into the formula and see which one's correct. Number 14. Determine whether the relationship in each table represents a linear relationship. Linear because it's got to be a constant rate of change. If it is not a constant rate of change, it is not linear. Okay, so find your constant rate of change. If it's not a constant rate of change, it is not linear. Read the answer all the way through because they're going to try to trick you. When you read something that's false, cross it out. Number 15, determine the slope and y-intercept of each linear equation. So again, I want to move y equals mx plus b. I want to get y by itself, and I want to move a negative 2x to the other side. I'm going to let you do that because I've done them plenty of times. If you've forgotten, you need to go back and look. Number 16. Write an equation in the form y equals mx plus b of the line shown in the graph. Then give the y-intercept, the slope, and the x-intercept. So remember, x-intercept and y-intercept. Those are the easiest ones to find. I'm going to follow down and find my y-intercept. And then you're going to come across and find your x-intercept. And then your slope, it's a positive slope, so it's rise over run. And then you should be able to find your formula. Number 17. Determine whether the relationship in each table represents a linear relationship. Okay, remember linear means it has a constant rate of change. Okay, so find your rate of change. Read carefully, mark out anything that's false. Number 18, write the equation of the line that is represented by each table. Okay, so let's look. Y equals mx plus b. B is your y-intercept. Remember, x has to be 0, and your y will be on your intercept. Slope is your change of y over change in x. Okay? And remember, just because it doesn't have a 0 for x, find it. What would go here if 0 was my x? If you find your constant rate of change, won't be a problem. Okay? Number 19. Cecil has a balance of $80 in her internet music account. She spends $5 each week for the next 5 weeks. If you were to graph the linear relationship, what would be the numerical value of the slope? What would be the slope? What would the slope mean? Remember, she is spending $5. Look at the wording on your answers. Number 20. Determine whether the relationship in each table represents a linear relationship. Linear means it has to be a constant rate of change. Find your rate of change. Constant rate means it is linear. Number 21. The table represents a linear relationship. What is the sum of P and Q? Use problem solving. What is the sum of P and Q? P plus Q equals your sum. Okay? You have to find what is P and what is Q. So, find your rate of change. This one's hard, so I'm going to help you through it. Rate of change. For your x, from here to here is going to be 8, and on your y's, it's going to be 9. But if I want to go right here in the middle of it, what would I need to do? Divide by 2, because that's the middle. I want to find what is the middle. So divide by 2. And then, when you do that, you'll find out that we're adding 4 to each side, and over here, we're adding 1.5. Now then, I need to subtract 1.5 from 6 to find out what my P will be, and then I need to add it to 6 to find out what my Q will be, and then add them together to find the sum. Last two. Determine the slope and y-intercept of each linear equation. Y equals 6x. Remember, just because there's not another number out there doesn't mean there's not a y-intercept. There has to be a y-intercept. What could I add there that wouldn't affect the value of this equation? There's been one like it before. If you forgot, go back and look. 23. What is the slope of the line containing the points in the table below? Remember, change in y of your change in x. Change in y of your change in x. If you have any questions, ask them on Google Classroom and we'll get back with you as soon as possible. We should be in the morning before school if you want some tutoring.